Hello and welcome to today's European SharePoint Office 365 and Azure Community webinar. My name is Shane and I'm delighted to be joined by Stefano Tempesta, Microsoft Regional Director and MVP at Avanade UK, who will be talking to you about distributed ECM with SharePoint on blockchain. Remember to join in the conversation about today's webinar on Twitter. Our Twitter handle is @EuropeanSP and our hashtag is ESPC18. Don't forget to check out the Resource Center. This is packed with the latest blogs, ebooks, webinars, and how-to videos. Simply visit sharepointeurope.com/resource-center. After the webinar, we will have a questions and answers session. Type any questions you have for Stefano in the question window. Some questions will be selected and answered at the end of the presentation. This webinar will be recorded and will be added to the Resource Center, where you will be notified by email when it is available. And now I'm going to pass you over to our webinar presenter, Stefano Tempesta. Hello, Stefano.
Hi, Shane. Hello, everybody, and thanks for joining us for this webinar. Let's talk about blockchain, and let's talk about blockchain in the context of enterprise content management. So, really, I want to share some experience. Application of a blockchain in this space, the space where we normally operate with SharePoint, with Office 365, document, not only storage, not only versioning, but also document signing and verification. And we do this in blockchain because blockchain provides an immutable storage system where we can store, indeed, information that we don't want to change. This can help us providing some proof that documents exist and they have not been tampered with. And we'll see how this is relevant to which industries and also how this is implemented. All right, so very briefly about myself, you can see some social coordinates on screen. If you want to get in touch, feel free to network. If you have any follow-up questions, as Shane mentioned, type your question in the chat box or follow up with me after this webinar. I'm a Microsoft Regional Director and MVP on AI, artificial intelligence, and business applications. And blockchain is a sort of passion of mine. I've been doing blockchain now for more than a year. And my interest in blockchain is really in the enterprise space, not in investment, not in bitcoins and cryptocurrencies, but really try to see how this technology can be applied to several industries and resolve some challenges. And today we'll see a few of these in the context of ECM, enterprise content management. But before we get into the core of the topic for today, just a brief recap on how we landed with blockchain in the enterprise, because blockchain actually started as a distributed ledger, completely decentralized for processing transactions in a peer-to-peer network. We are all familiar with the traditional system where we rely on a central authority to authorize some form of transactions. Think the most common use case when we make a payment with a credit card or when we withdraw some money from a cash machine, an ATM. We'll typically interface with a credit card institute or with our bank, and this is the central authority that grants access to funds, to our money, so that we can transfer from to another person, to another entity. Now, in blockchain, we don't have a central authority anymore. So what's the role of the central authority? To authorize the transaction and making sure that we have enough money and that this money or this digital asset that we own is stored in a ledger, no? Which is a sort of a huge spreadsheet, if you want, where there is a list of all the transactions in input, in output, debit and credit, when this is done, to whom, and the amount. Now, this digital ledger in a blockchain is distributed among all the peers, all the nodes that are part of the network. So it means that everybody has a copy of this information, but no one actually owns it. And it is also decentralized because there is no central authority that approves the transaction itself. But the transaction is approved as a form of consensus. If the 50% plus one of all the nodes in the blockchain system, in the network, agree on the transaction, then this can happen. So what is this transaction exactly? So say that Alice wants to send some money to B, to Bob. The transaction is represented as a block, as a collection of pieces of information that defines the two parties involved, when this transaction is happening, the amount that this is related to. And now I'm talking amount because probably the most common case for transaction is sending money, cryptocurrencies. But as we will see today when speaking about ECM, there is no money involved at all. We are actually transferring information about documents, so digital assets in general. Now, this block is then broadcasted to all the parties, all the nodes in the network. This block has to be verified. There are different mechanisms. They're called proof of work, proof of stake. There are different ways to verify that a block is correct, is genuine, because obviously you don't want counterfeited information to be broadcasted in the network. And then this block, once it's been validated, is added to a sequence of blocks that together builds a chain, hence the name blockchain. And this chain is immutable. So it means that you cannot remove a block. You create a sequence of all these transactions that you can only append to, so create a new blocks, but you can't remove existing blocks. Now, how is this going to help in our case? Well, if we refer only to this form of blockchain, let's call it blockchain 1.0, Bitcoin, to make it simple, then I don't think we will have a lot of application in the enterprise space, because this sort of blockchain can only authorize monetary transactions at the end. That's what Bitcoin is. We need some form of advanced blockchain that introduce also a logic tier. So some form of business logic that not just authorize transaction because I have enough money or not, but also because there are some other conditions that are verified, as part of, for example, document checking. And so this is what typically is identified as a blockchain 2.0, which has introduced also the concept of smart contracts. So this blockchain 2.0 is still missing something though. It's still missing connection to external systems. Now, the world of blockchain and the world of smart contracts work in isolation from any other networks. So you're probably familiar to Ethereum, Hyperledger Fabric, Corda, and so on, all these different type of blockchains, they are network of nodes that work in completely isolation. They don't talk to each other, first of all, and they don't talk to external system. They are self-contained, and this is part of the security that blockchain provides. Now, the real world is not an island, and we need to create a form of dialogue with a CRM system, with an ERP system, with a website, with an intranet, with an Active Directory where we store identities and so on, with SharePoint, with Office 365, with OneDrive for business and so on. So we are missing in blockchain 2.0 the connection to the external world, to off-chain data. And this is what has been labeled as the evolution of blockchain as a 3.0, where Microsoft has pioneered some frameworks and some technology that we are going to explore also today that allow off-chain data in a secure way. So the possibility to connect blockchain to SharePoint, for example, or the other way around, SharePoint to a blockchain backend. Now, I will probably talk about blockchain for hours and hours, and this is a bit out of scope in some way, although I would love to. So I just help you to introduce yourself to blockchain technology if you are new to it, with a couple of references on screen. So I like the geeks.com or geeks.com website. They have a lot of guides about blockchain and a bit of self-reference, if you don't mind, about my own blog about blockchain technology. So yeah, it will help you getting started with blockchain technology if you're new to this world. So let's now speak about enterprise content management and how blockchain can resolve some of challenges. What kind of challenges? You will see this on screen. Probably the first one is the most critical. We want documents to be authentic, not to be tampered with, and we also want to verify that these documents exist. And when I say documents, actually take it as any form of digital asset. It doesn't have to be a Word document or a PDF. It can be a PowerPoint slide, it can be an image, a video, any digital asset that we can store in an enterprise content management system like SharePoint and verify and sign, as we will see. I have also a brief demo. Now, some of these documents or digital assets as a videos, as a song, tune, an MP3, have also some copyrights with it, some owners that wants to protect their intellectual property. Now, blockchain can also help in this space because being immutable as a storage system, as a ledger, it allows to store information that cannot be modified. Now let's reflect a bit on the audit trail concept. We are all familiar with the audit trail, no? With the possibility to verify any sort of actions that someone has done on. I have some direct experience with healthcare and also education, which is not on screen here in the slide, but is extremely relevant to digital records that you want to sign and verify. It's all about removing third-party verifiers, so central authorities that you have a where you have a dependency on for sharing documents and signing this document. So I want to walk you through a specific use case and show how this applies also in the context of SharePoint. So we do this together with two friends of mine. So let me introduce you to Laura. Please meet Laura. Laura is a student. She's 20 years old from the Netherlands, and she wants to live and work in Australia after her graduation. Now, to immigrate to Australia, she has to provide a good number of documents. She has to prove knowledge of English, all her certificates from her universities, and obtain eventually a working visa. This is taking several weeks. It's taking some good time for Laura to get all the paperwork ready and even translated from Dutch language into English and share with the Department of Immigration to Australia. She's quite frustrated because this process is taking really a long time to be completed. Now let's meet Robert. Robert is Austin instead. He lives in Sydney and he's a doctor. Every other year he goes through some update of his skills and programs, recertifications, and then registration with the healthcare department to be authorized to progress as a practitioner. Now, this again is frustrating for Robert because he's got patients to look after, not paperwork. He has to prepare all the certificates, submit to the healthcare department, and go through this process all the time again, which again is time consuming and exactly not optimal. So what do Laura and Robert have in common? Have a challenge of documents that need to be verified by some authorities and approved for being authentic and in order to grant, in the case of Laura, a visa to Australia, in the case of Robert, a license to operate as a doctor. So now let's enter into the demo of document signing and verification. This is based on a SharePoint portal that integrates with Ethereum backend through a set of APIs powered by a technology called Spherion that provide exactly this form of signature and verification. Let me show how that works and then I explain a bit better the process itself. So I get off my slide here and go into my SharePoint portal. So hopefully you can see I'm in the Marvel University portal and I have access to certification for documents, for any type of documents like diplomas that I may have. So in this page, I want to prove that a document exists. So the proof of existence of a document, and I do it by first of all identifying myself with my digital identity. In this case, this is provided by my email address, so I can just type my email address for identifying myself in the system, and then I can upload a file that is my diploma. So I have this diploma from the Marvel University. What is in there? Well, let me show you this very quickly. Let me go to my documents, open my Marvel University diploma, and you hopefully can see that I have a diploma of superhero issued on year 2000 by the principal Bruce Wayne. So that's perfect. So now with this diploma of superhero, I can upload it into my SharePoint portal and SharePoint will start the communication with my blockchain backend. What happens? It happens that I sign this document and I get this big number here, this alphanumeric hash code, which is unique to my Marvel University diploma.pdf document. Okay, so what happened basically, and I'll get to my slide to describe the process. As a user, sorry, as an institute, so in this case, the Marvel University, I issue a certificate, I issue a diploma. This diploma is actually stored in SharePoint, or it can be in any storage. It can be even in a distributed storage like IPFS. For the sake of this demonstration, it is in SharePoint. And then using a set of APIs for talking to a blockchain backend, I identify this document with a unique identifier, with unique URI, with a timestamp when the document is issued. And this API in the blockchain generate a hash code. Now, a hash code is unique for any combination of bytes, even bits. So what I mean is that if you just change one single character, one single byte in this document, the hash code would be completely different. And an hash code is also, let's say, quite impossible to decrypt because it's a sort of one-way encryption. So now let me show you what happens if I want to verify this document. So basically, if I'm in the scenario of verification as an authority, in the case of Laura, her university issued a diploma. She will submit this document in PDF format to the Department of Immigration in Australia. But everybody can Photoshop a document at the end. Instead, if this document, these certificates were stored on a blockchain network, the authority will only need to verify directly from there and optionally retrieve it from the actual storage if they wanted to save the digital asset. But otherwise, all they need is basically create a transaction and verify that this information, given the URI, the hash code, and the timestamp, is unique for this specific user and for this specific digital asset. So the way it works basically, and I'm going back to my demo portal, is that as an authority, let me switch to my verification page. I will upload the file that you can see is exactly the same and check that this is correct, this is still valid. Now, you wouldn't need to upload a file. You can just use the URI to retrieve the file. In my case, this is sort of a demo, so I'm uploading documents every time. And hopefully this shouldn't take too long. Or let me refresh the page just in case we had a session timeout before, which is always a sign that I talk too much. So let me just refresh the page and try again to upload the file and try again. Hopefully here we go. This file has been received and green tick. The file is being registered and is in the expected format and content has not been modified because all this information has been already stored in the blockchain backend and is now being verified. The hash code basically matches. Now, but what if I try to tamper with this document? So let me get to my Word document where I have this diploma, and let's say the requirements to immigrate to Australia is no longer to have a diploma of superhero, but you want to be a Power Ranger. Okay, that's what we need in Australia. So let's now save this as exactly in the same location, exactly in the same format, exactly with the same name. So I replace the existing document. So now I'm working on my local system on my laptop here, but pretend this is happening in SharePoint. So I'm creating a new version of the document that contains the, yes, I will need to close it in PDF. Here we go. So let me save this again. So here we have, I'm now a fake Power Ranger because I counterfeited my degree, my university certificate. And what happens is that if I now upload exactly the same file, now the hash code that is generated for this file will be different, and obviously the verification will fail. Okay, so the process of verification now started from the this metadata describing this document in a unique way, prove that the hash code is different, hence the document is different. I don't need to share the document with my authority. All I need to do is to initiate a transaction, as in Bitcoin, where I create a transaction between two parties, and now this transaction is not transferring any money, it's just authorizing the, it's just transferring information about the URI, the hash, and the timestamp of the certificate that I want to share with the authority. And because this certificate has been already verified before, I mean, it's been issued by an institute and stored with this information in a blockchain, and the blockchain is immutable, I know that is genuine, that is exists and has not been modified by any other parties. So how do you get started with all this? Now, you can start with any blockchain network like Ethereum or Hyperledger. I normally use blockchain as a managed services in Azure. And I do so because Microsoft offers sort of blockchain as a service really in the Azure cloud, with the possibility to install or to create an Ethereum network or an Hyperledger network in really minutes. So if you think of what a blockchain is, is a combination of different resources for computing, networking, storage, virtual machines. They run on a Linux box typically. And then there is some proprietary storage and computing mechanism for hashing, verifying, consensus, proof of work, and so on. Now, all of these, if you were to install by yourself, will take some effort. Microsoft offers this infrastructure as a service in the Azure cloud, so you can focus on the implementation of your business logic, so develop your smart contract directly in Ethereum or in Hyperledger or in any other blockchain system, and leave the management of the infrastructure to the expert, to the Azure guys. So let me show you how this looks like, although we won't enter too much into the detail. So in my Azure portal, hopefully some of you are familiar with the Azure portal, you can create a resource from the Azure Marketplace. And the last, for some reason, is the last in the list of categories in the marketplace. You can see I have blockchain here. And let me expand all, what you see in the offering of services, you can see that we have different ledgers, single node or multi-node ledgers. Typically, a single node ledger is a ledger that you use for your own testing purposes, and then a multi-node ledgers where you join an existing network or create your own network. You can create Ethereum, you can create a Ledger Fabric, Quorum, Corda, and a few others. So if we were to go, for example, for Ethereum, and you see Ethereum is available as a proof of authority, but there is also, if I expand here, there should be also proof of work somewhere, or maybe not. There was until a few days ago. Strange. Okay. Anyway, so if you carry on like this and then you create your Ethereum, it will go through a wizard that asks for some basic settings, some deployment settings, which region you want to deploy, some network and performance sizing. So how many nodes do you want in your network? What is the sizing of your virtual machines? And then in about 15-20 minutes, you have your Ethereum network up and running. So not to get confused with the public Ethereum that runs on the Ether cryptocurrency. This is still based with the same technology, but is your own implementation of Ethereum, and that you can use for for developing, testing your smart contracts before publishing into the public Ethereum, or you can use to build your own private or consortium blockchain. But this is a long talk, maybe for another time. Another tool that I want to point your attention on is the blockchain workbench. The Azure blockchain workbench actually is not just, so to speak, a network, a digital ledger, but actually is, as you can see here in the screen, is a combination of many different systems, the Azure system. There is an app service, there is an event grid, there is a service bus, there is an Active Directory, there are some virtual machines, there is a SQL database also for some off-chain access. There are many different systems. Only talking about blockchain workbench will take hours and hours. So my point here today is just giving you some pointers to get started with blockchain and get started with blockchain in Azure, because it provides this level of managed services where the infrastructure is completely managed in the cloud, and then you can focus on building the business logic that you have seen before, for example, for signing a verified document, and also the integration with third-party systems like SharePoint. So in brief, Ethereum as a service can be offered as a proof of work, which is the public Ethereum, a consensus mechanism that is very computational expensive. You probably have heard that proof of work mining a Bitcoin is something that is extremely expensive to run from an electricity utility bill. There are other ways of doing mining based on other consensus mechanism. A very popular is a proof of authority, where you don't need to do actually the mining at all. You rely on some special nodes, special accounts that are called validators that have the authority to validate this transaction for you. Now, this works better in a private or in a consortium network where you know the identities of all the nodes, rather than in a completely public anonymous network like the public Ethereum or Bitcoin. And blockchain workbench is really your blockchain as a service where you forget about your virtual machines, your service bus, your event grid, your Active Directory. Everything is hosted in Azure. You focus on building a smart contract, and then you publish the smart contract in the workbench, and the workbench basically looking into the metadata of the smart contracts defines a user interface for running workflows with no coding. So this client creates a UI for running this blockchain workflow directly from the definition of the smart contract. These workflows can talk to a SQL Server database, to a Power BI, even to a machine learning studio. They can exchange data with the outside world, and they can accept data from the outside world because they're all part of a network of entities, systems that are secured and validated using a combination of Active Directory for managing entities, Key Vault for using your primary keys for cryptography, and so on. There is a lot that can be said about blockchain workbench. My idea here is really giving a few pointers how to get started with blockchain without being intimidated by the complexity of creating a blockchain network by yourself. And if you like diagrams, the architecture of a managed blockchain in Azure basically contemplates different services where the blockchain ledger here in the middle is only one of the many systems that are part of this overall architecture. You can connect different data sources, different apps, even IoT devices to an ingestion hub, basically to a hub that collects data from different sources, and these information, these data flows into the digital ledger, the blockchain ledger, if you want to store something in an immutable storage, like an audit trail. And obviously, this data also can be provided externally through other applications that consume these services using an event hub for capturing and processing any event that execute inside the blockchain ledger. So in the context that we have seen before of document signature and verification, an event is when a document is uploaded that generates an hash for this document, an hash code, and then so basically a signature, and then the process of verification is another event that again creates a dialogue with an external system, and this event is again raised against the digital ledger. And now I'm speaking generically as a digital ledger in a blockchain because the technology that Microsoft has built is based on a framework that abstracts from the specific blockchain platform. Currently, it works on Ethereum, but the roadmap is to make it generic, so independent by the specific blockchain platform. It can be Ethereum, it can be Hyperledger Fabric, it can be Quorum, it can be any blockchain network that support this kind of integration and event handling. So this is something that we expect in the Azure blockchain implementation to happen. a level of abstraction so that you can focus on your business logic irrespective on the technology, the blockchain technology that is behind. And I think we are at the end with a bit of hiccups, and thanks for your patience. Let me catch some question now, and as said at the beginning, feel free to get in touch for any follow-up. I'll be happy to connect with you guys and provide any other further clarification.
Stefano, thank you so much. Yes, a few hiccups at the start, but I think we got there in the end. So thank you for persisting on today's webinar. Can you hear me, Stefano?
I can hear you, yes, I'm here.
Oh, great, brilliant. I thought we'd lost you there for a sec. Thankfully, there's no questions at the moment, Stefano. We might just give people 1 or 2 seconds just to see if they want to get a question in. They can do so via the questions window should you wish. But in the meantime, I would just like to thank you for your time today, Stefano. Very much appreciated in going through this today, and the feedback is from the people who are saying thank you as well. So thank you, Stefano, again on behalf of the community for taking the time to do this webinar. We have one question that's in. It goes, do you know when exactly the blockchain 3.0 will be available? I could have missed it in your presentation.
Right, okay, so you can already connect to external system, so what we call a blockchain 3.0 using blockchain workbench. Workbench use Azure Service Bus for inbound messages with the publish subscribe pattern. Basically, the digital ledger in blockchain is the listener to messages that are coming inside from the external world, so the access to on-chain data, and then raises events. So any events that are raised inside the digital ledger are processed by our event grid, and as an external application, a mobile apps or an external website, you can just handle all these events and process them accordingly in your external application. So this is already possible. Use the Azure Blockchain Workbench for writing your smart contracts and connecting to off-chain data.
Great. Thank you, Stefano. I'm just going to take back the screen and just wrap this up. But thank you for your time today. Very much appreciated. Super. Okay, so thanks for a great presentation from Stefano. Please see sharepointeurope.com register-for-webinars for further details on all upcoming webinars, or visit our resource center for all previous webinars. Thank you all for joining us today. Apologies about the technical difficulties. Take care and goodbye.